on this because the unit circle kind of tells you how the graph goes. So the idea is to get an understanding of how the graph of a sine goes, we're just going to make a table of values. That's how you learn to graph anything, is you make a table of values. So really all I got to do is the sine is the y value. So you want to go ahead and just fill out this table of values. You can look at the unit circle I have up here, and I'm going by pi over 2. I'm just going by 90-degree increments, and then the value of the sine is going to be that y value. So notice the sine of 0 is going to be 0. Sine of pi over 2 is going to be 1. Sine of pi is going to be 0. Sine of 3 pi over 2 is going to be -1. And then when you're at 2 pi, of course, that's one lap around the circle. So you've got that then. Okay, just look at the y value. If you go backwards with this, it's going to go like this. So if you go to negative pi over 2, then that's -1. If you go to negative pi, it's now clockwise. That's back to 0. And then it would be back to 1 and back to 0 like that. So all I'm doing is just looking at the y value on the unit circle to get those values, because that's what a sine is. Okay? All right, everybody okay with what I just did? Okay, all right. Now, what we're going to do is we're going to just draw the graph. Now, you want to label everything. So we're going to just label the x's the way I gave you. I picked these numbers on purpose because these are kind of the special numbers in this graph. So you want to label your x-axis. You have pi over 2, pi, 3 pi over 2. Anytime you're giving me a graph, you need to have everything labeled. If you don't label, then how do I know if you're right or wrong? I don't know. So you got to tell me what your x values are. Okay? So let's go ahead and get that set up. Okay, and then the y values, notice the y values went from -1 to 1 and 0. They alternate. So let's kind of go like this. Let's just put like a 1 up there, down there. However you scale, that's okay. All right, so let's just go like that. Okay, then let's just plot our points, and let's see what this graph looks like then. So I'm going to start here. -2 pi, you have 0. -3 pi over 2, you have 1. Then back to 0. At negative pi over 2, you're at -1. And you're going to find the sine is just going to alternate through these values over and over again forever. Got 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi like that. So it just jumps up and down between those values. But it's a nice smooth curve. So when you graph this and connect these dots, you want to do that in a nice curve. It doesn't have any sharp points or anything to it. It just looks like this. Okay, so that would be how the sine wave goes. All right, that's all there is to that. All right, let's get the calculator out. You're gonna do most of your graphing here without a calculator, because you don't really learn graphing very well unless you learn how to do it by hand. But I want to take you through how you would do this on a basic graph then. So the first thing you'd want to do is go to your mode button, and you want to make sure you're in radian mode. We're always going to do our graphs in radians. We're never going to do that in degrees. So your x-axis is always going to be like that. Okay, let's see. For y equals, of course, you just go to y equals and put in sine of x. And then I'll show you kind of how you do the window. Whoops. Okay, so I'm just going to y1, put in sine of x. Okay, and then your window, we're going to set up the window just the same way the table of values goes then. So I'm going to go, for x minimum, you just put in -2 pi, because we're in radian mode, so the calculator is going to know what we're doing. For x max, we're going to put in 2 pi. Okay, like that, and then we're going to scale by pi over 2. And what the calculator does, it just changes these things to decimals. Okay, we're going 90 degrees like that. And then the y value, we can go -1 to 1, just like we did, and then scale by 1 like that. So if you graph that, you'll see the sine wave. I want you to just see how it's curved, and there's no sharp points on that or anything, okay? So that's your sine wave, like that, and it'll do that forever. The angles get infinitely big, infinitely small. It's that same wave to infinity in both directions. So that's what your graph of your sine wave looks like. If you do graphing, just make sure on trig that you're in radian mode, okay, or it isn't going to do the right thing. Okay, so a few things that we want to kind of look at in our graph here. All right, so basically a couple of definitions. The general shape repeats itself over and over again, so we call this a periodic function. All of the trig functions are what we call periodic functions because they have a certain shape that repeats over and over again, like this. Okay, so first of all, we have a distance. The distance measured by x values from the beginning of the wave to the end is called the period. Okay, so that's important you write that down, and that's kind of, it's a periodic function, so a period tells you that piece that's going to repeat over and over again. Okay, we often call it a sinusoid. A sine is called a sinusoid a lot, and then the key points are like this. So basically, I just want you to kind of label this like this. You can start anywhere you want on this, but I'm going to start the sine right here. Okay, so that's key point number 1. Key point number 2 is the maximum. And then the midpoint is that point right there. You're halfway through the period. Then you get to the minimum. So that point is the 4th key point. Then you're at the end point like that. So basically what's going to happen on a sine wave is this is the period. From there to there is a period. You're always just going to go 0, 1, 0, negative 1, 0 forever and ever again. So the distance from the start to the finish is called the period, so that's 2 pi. So every time 2 pi goes by, the sine goes through that cycle. Okay, so what we would say is basically this. The period, you probably want to write this down. The period is 2 pi. That's 2 pi units. Okay, so that's what repeats over and over again. Okay, any question about that? Okay, 5 key points. You're going to find that every trig function that I teach, we're going to always talk about 5 key points that define that period. Okay, the domain on a sine is all real numbers. If you look at the unit circle, you always get an answer. You never divide by 0. Trig functions are undefined when you divide by 0. And since the sine is the y value, it's always defined. Okay, there's no breaks in the graph. What's the range of this graph? Where to where? Negative 1 to 1, right. Okay, so we could just write the range if we want to in set builder or in interval notation as negative 1 to 1. Okay, so that's the range on that. The biggest value is 1, smallest is negative 1. You can look at the unit circle, and the unit circle tells you that. The biggest y value is 1, the smallest is negative 1. So that's your range. The y's range from negative 1 to 1. Okay? Okay, so let's see. Next page, we're going to do the cosine. The cosine is done the same basic idea, and it's going to look a lot like the sine. It's not the same graph, but it sure looks a lot like it. So we're going to do exactly the same thing. Okay, so how do you find a cosine on a unit circle? What do you look for? And my students enthusiastically answer x. Okay, just checking to see if you're with me or not. Okay, we have the x values. Okay, so that's what we look for on a cosine. All right, so when we fill this out, the cosine of 0 would be 1. Cosine of pi over 2 would be 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. And then the cosine of 2 pi is back to 1. Okay? And then it just goes backwards. The cycle goes backwards. So if you're at negative pi over 2, that's 0. Negative pi, it's negative 1. Then it's back to 0. Then it's back to 1 like that. Okay? So the unit circle will tell you how the graph of the sine and cosine goes. You figure it out from that information. All right, so just like the last problem, let's go ahead and let's sketch a graph. You want to go ahead and just label your x-axis. And we're going by pi over 2 when we do the basic trig functions. And the wave is going to look a lot like the last one. It just has a different starting point. And then you can do like we did there. We had 1 and negative 1 like that. So you can go ahead and just kind of plot your points, and then it'll give us what the cosine wave looks like. So just put your points on there. Okay. Just going to cycle between these key points just like the sine did. And once you get the hang of this, you can do these graphs like super fast because you know how the pattern goes. All right. And then what would happen with the cosine again, when you connect the dots, make it kind of a nice smooth curve, sort of like that, okay? So that's what that looks like. So it has the same kind of shape to it. What I want to show you, though, is the only difference really between the sine and cosine is basically this. I'll go back to this page here in just a second. Just want to show you so you can see these things side by side, is the idea with the sine here is the sine starts in a different point. So they're the same basic shape and everything, but the sine starts at 0, 0. I think that's important to remember. But then the cosine starts at 0, 1. But it's the same basic thing. You're going to find, those of you who have had trig or pre-calc before probably learned about phase shifts. Really, the sine and cosine are just transformed this way. Okay, we call that a phase shift. We're going to get to that a little bit later. All right, so a couple of observations on this. It's the same basic stuff, okay? The distance from the beginning of the wave to the end, again, is the period. The 5 key points are the starting point, the maximum, the midpoint, the minimum, and end point. And it doesn't really matter where you start on this. I usually just do like this. I usually tell students, okay, remember the cosine starts at its high value, okay? But you can start anywhere you want to. Then this would be the midpoint. That would be the minimum. This is another midpoint. And then that's the back to the maximum like that, okay? So what you want to remember is the sine starts at 0, 0, then cycles through the points. The cosine starts at its maximum and cycles through the points like that. That's an easy way to remember that, okay? And all this stuff on this page is the same. The domain of the cosine is all real numbers. Cosine's always defined. And then the range is -1 to 1 like that. All right, so those are the basic graphs. Students usually have no problem whatsoever learning the basic sine and cosine. It gets more complicated when you start putting transformations into it, which is, of course, what we're going to do. Trigonometry, we do all the transformations the way we do any function. We do have kind of special names for those transformations. All right, does anybody have any question about what we did there? That should be like super easy, getting a basic sine and cosine. And you want to get that memorized if you can, so the more complex graphs you do, you can speed up the process of doing your graphing a little bit easier, okay? All right, well, down at the bottom of the page, I'm going to introduce you to the what an amplitude is, okay? And the amplitude is defined to be 1/2 the distance between the maximum and the minimum y values, okay? So you're going to find that the sine and cosine have an amplitude. There's a specific distance between the min and max, and the amplitude's always half that distance, okay? So you do 1/2, and you find this is wrong right here. You guys need to correct this. This is 1/2 the maximum. I think this thing didn't export correctly. The max minus the min like that, okay? All right, so you're doing the y values, and then the amplitude is a distance. So a distance is a positive number, so an amplitude is always a positive number then, okay? Where have you heard the word amplitude, by the way? Out in the quote-unquote real world. Radio? You know what AM radio is? That stands for amplitude modulation, and that has something to do with sound waves, crests of the waves being modified. Okay, when the signals come into AM radio, they're defined by the height of the waves that come in. FM radio is called frequency modulation. That has to do with how frequent the waves are. If they're real frequent or they're stretched out, okay, and it actually impacts the sound quality on that then. And AM radio carries a lot further than FM radio does for that reason. Okay, so it's two ways to detect a signal, basically. Okay, so on the next page, this just shows you a diagram of what an amplitude is. So what you always do is you always look at the peak, and then you look at the bottom, the minimum like that, and you do half of that distance, okay? So that's what we're going to look at, is half that distance between the crests of the waves is what the amplitude is, okay? All right, well, let's just crunch this out real quick, and this is real simple. So this is the graph of the sine. The maximum is 1. So you have a maximum y value of 1. The minimum is negative 1. So what you would do is, how far apart are negative 1 and 1? Negative 1 and 1 are 2 apart, right? Well, what's half of 2? Half of 2 is 1. So the amplitude's 1. So what you're really doing is you're doing half the distance between the max and min. Okay, so it's just half of 2, so you get 1. The amplitude is 1. So really, when you're looking at an amplitude, you're looking at this thing right here. The distance, and don't think of it as the x-axis, because you can move the waves up and down, do vertical translations, so it's half of that distance right there. So all it is half of 2. That's it. Okay. How about the cosine? Is it any different? Does it have the same amplitude or a different amplitude? Does it have the same max and min? Yeah, so it's got to be the same. Okay, the minimum value on the cosine is negative 1. The max is 1. So again, the amplitude's 1. So again, it's just this right here. It's half of the distance between those two, the max and min. So half of 2 is 1. That's it. Okay, so that's what the amplitude of a basic sine and cosine is. All right, now getting down here, what we're going to kind of begin to look at is the equation. So what happens is, and you learned this before, I want to kind of see what you guys remember on this for a minute, and you don't need to write this down, but you know x squared's a parabola, right? What happened when we learned about a parabola? If you do 2x squared, what's the difference? What did you learn? What does that 2 do? It does something to that parabola. It multiplies the y values by 2. If the y values get multiplied by 2, what happens to the graph? It starts stretching, doesn't it? Okay, so this is like a stretch, like that. Okay, and how about if we did 1/2 x squared? What did that do? Y values get smaller, shrink. Okay, so you want to understand the math behind how these things work like that. So an amplitude is really a vertical translation. It's the same thing, okay? So if you have a number in front of the sine or cosine, and if that number is bigger than 1, then it's going to stretch vertically because the y values get larger, okay? And if you do a fraction between 0 and 1, it's a vertical shrink because the y values get smaller. So you're not learning anything new. It's just that we're calling this an amplitude in a trig function. It's stretch shrink stuff. It's the same stuff. Okay? All right. Well, let's do a graph where we have an amplitude change. So let's do a couple of those and get this put together then. Now, ultimately, what I try to get students to do on trig graphs is not have to do a table of values at all, but we're going to start that way. Okay, so first thing we're going to do is do this. Now, you want to get this memorized. I'm going to just write this down. All you got to remember on a sine is the sine of 0 is 0. Remember, it's the y value. And then I'm just going to do this real fast. Then it hits its high value. Then it's back to 0. Then to its minimum and back to 0. And then you can go backwards. See this thing right here? That is one period right there. So if you go backwards then, it's going to go to -1, 0, 1, and 0 like that. Okay, so that is your basic one like that. Now let's go ahead. We're going to go ahead and graph both of these together just on a couple of examples. So go ahead and get your x-axis put together. And you probably want to go all the way up to 3 on this one since we're going to be graphing the 3 sine x. So you want to go ahead and just get your sine wave. I'm going to do the sine wave like in a dashed line, or you can do a different color if you want to. I just want to compare the two when we're putting this together then. Okay, and let's go 1, 2, 3. That's a sensible way to scale that. And then I'm just going to sketch the sine wave, but I'm going to do a dashed line. Okay, so you can do this super fast too. Once you catch on to the pattern, you can graph like in no time at all. All right, so that is the basic sine wave. The quicker you get the sine wave memorized, the better. But if you ever forget it, the unit circle will bail you out. You can figure it out with a table of values. Okay, so what happens is the y values, this is a good thing to write down. I mean, unless you've got this totally in your mind by now. The y values get multiplied by 3. Okay, that's what's happening. That's why it's going to be a stretch. So really all we're doing, and you can do this in your head, I'm just doing 3 times 0 is still 0. 3 times 1 is 3. You can just do that in your head. 3 times 0 is 0. 3 times -1 is -3, and so forth. Okay? So the zeros are unchanged, but the 1 goes to 3 and the -1 goes to -3. Okay, so that's what that's doing. So now you want to plot that, and then that'll be the final graph. All right, so you can take those points, and then that would go like this. The maximum would go from 1 to 3 now. You still have the same x-intercepts. The minimum stretches down to -3. And once you get the idea with this, you can do this, pretty quickly. So this would be what the final graph looks like, is like that. All right, that's all there is to it. Students usually in trig graphs have no problem with amplitudes at all. That's usually pretty easy to understand. Usually it's when you start having period changes and phase shifts when it gets a little bit more complex. All right, so what we're going to do is let's fill this out. And the amplitude of the sine is 1. The amplitude of 3 sine is what? 3. Okay, all you do is look at that number in front of x, and the reason is because since the y values get multiplied by 3, okay? That's why the amplitude changes to 3, so it's a stretch, okay? Right, everybody okay with what I just did? Okay, most it's arithmetic and plotting points. That's what I always tell students graphing boils down to. It's almost always the same. So let's go ahead and do this next one here, and then we'll take a break. I want to get you through the amplitude because after this, we start going to the period change. And that's a little bit more complicated, but if you follow what I teach you, you'll do fine. There's nothing to it. Okay, so this time I'm going to do this. Try to remember your cosine like this. The cosine starts at 0, 1. It starts at a high point, then it goes down to 0, then down to its minimum, back to 0, back to the high point. If you can just remember where these start, then you can fill out this chart super easy. Okay, so then it goes to 0, and then to -1, and then 0, and then 1 like that. Okay, now we're going to do exactly the same thing. We're going to graph the cosine, then we're going to do -1/2 cosine, and just kind of talk about how this goes. And you can go like this if you want to. I don't mind if you, just label the x-axis like pi 2 pi. I mean, as long as I know what the pattern is, that's okay. And then this time, I think we'll go all the way up to, I'm going to go up to 1, and then I'm going to put a half in there. So it's a good idea to stretch your graph out. A lot of times students, when they give me graphs, they make their scale so tiny I can't see what they're doing. Kind of widen it out and use up a lot of space on that then. Okay, so what's going to happen then when we graph the cosine, you can go ahead and get your original points plotted. And then we'll talk about what the 1/2 is going to do to this thing then. Okay. So 2 things are going to happen on this graph. What is the half going to do to the y values? Is it going to make them bigger or smaller? Smaller, so it's going to shrink. What is the negative going to do? You learned that before. If you have x squared and negative x squared, what does the negative do? It reflects you over the x-axis, exactly. So see, we're going to do this and just do most of this in our head. So to get what goes here, we just go -1/2 times 1. Well, that's -1/2. -1/2 times 0 is still 0, so that's unaffected. Then you do -1/2 times -1, that's a half. Okay, so what's happening is the 1's go to a half and the signs change. The zeros stay the same. So the 1 will go to negative 1/2, 0 stays the same, negative 1 goes to positive 1/2, and so forth. Okay, so all of that I did there was arithmetic. I multiplied every y value by negative 1/2. Then I can plot, and you should see what I want you to see, hopefully. So negative 2 pi, negative 1/2 would be down there. Still got the x-intercept the same. And then once you usually get about 2 or 3 points, then the rest of it, you just kind of put the dots in because it's going to follow that same pattern forever and ever. All right, so what you should see on here is it got shrunk, the amplitude changed, and then it also reflected over the x-axis, okay? So that's it. All right, so what is the amplitude of negative 1/2 cosine x? Is it negative 1/2 or is it 1/2? It's 1/2. It's always positive. Amplitude is a positive number. So what you do is really you do you always do the absolute value of the number in front of a trig function, and that gives you the amplitude like that. Okay. So that's going to end up, the amplitude of the cosine's 1. The amplitude of the negative 1/2 cosine x is 1/2. And again, that's because you multiply y values. And you're really multiplying by negative 1/2. That's what causes the reflection like that. Okay? And the other thing is the amplitude is just half of this distance. The distance from negative 1/2 to 1/2 is 1. Half of 1 is 1/2. So you're really looking at from there to there. That's your amplitude. Okay? That's it. Okay? Everybody okay with it so far? Okay? This is the easy part of trig graphing is the basic ones in amplitude. Amplitudes are pretty easy. Period and phase shift where it gets a little bit more complicated. Okay, let's go ahead and take a 5-minute break here. All right, so first of all, on the top of the next page, you want to do this just quickly in your head. If you want to know the amplitude, again, all you do is look at the number in front. Okay, and it's always the absolute value of that. So the amplitude of this function would be 10. The amplitude of this function would be 5. Okay, just remember an amplitude's a distance. Well, what happens on this is there's no up-down movement on this, so that means the maximum is 10 and the minimum is negative 10. Okay, so that's how easy it is to find the amplitude then. And then on this one, the max would be 5 and the min is negative 5. It does reflect the graph if you multiply by negative 5, but it doesn't affect the max and min. Okay, they just flip-flop the order. And then these next two are basically the same thing. Okay, so the amplitude of this one is positive 1/3, and that would mean the max is 1/3 and the minimum is negative 1/3. And this one, the amplitude is 8.5, which would mean the max is 8.5 and the minimum is negative 8.5. Now what's going to happen, it's a little different. We'll get into this in a little bit here, but if you had something like 10 sine x plus 5, well, then the amplitude's 10, but everything gets shifted up 5. Okay, so the max and min are not the same as the amplitude, so that can happen. All right, so what we're going to look at next here is the idea of a period change. So we look at what happens when we put something in front of x. I think this thing is supposed to say sine of bx, like that. Okay, so what happens is when we put a number in front of x, that changes the period. Okay, so it's kind of like a stretch shrink horizontally like this. So what's going to happen on this is this diagram is just showing you the period and then the different cycles. So again, you always have 1, 2, 3, 4, 5 key points make up a period, and that makes up a cycle, and then it moves on, forever and following that pattern. Now, when you learn how to graph where there's a period change, just follow exactly what I'm teaching you because it makes it easy. I'll kind of give you that idea. A couple of formulas that are pretty important down here is I just showed you how to get the amplitude. Now, we have the formula for the period on a sine or cosine is 2 pi over b. I think our textbook you're going to see, and you'll see this on my math lab, you'll see omega x. And you'll see cosine of omega x. It doesn't make any difference. It's the same thing. you just divide by that value. So my math lab is probably going to show you that formula is 2 pi over omega, okay? And if that value is, depends on how it is, whether it stretches or shrinks it. So I'm going to show you how to do that. So this is really the whole key when you do this, is when the period changes, you need to change the x values. And what you do is you find the period, and then you find what's called the increment, and I'll explain that in several examples. That tells you how to change your x-axis. The graphs we did so far, the x-axis went 0, pi over 2, pi, 3 pi over 2, and 2 pi. Well, if you have a period change, you got to change that. Okay, that's the key thing that's going to happen on that then. Okay, all right, well, let's go to the next page, and I'll show you how to begin to put this together then. Okay, and we're going to we're going to continue to do the basic graph and compare it to the transform graph when we do this then. Okay, so let's not do our graph, let's just get the table kind of filled out first of all on this then. So what you want to do to begin with, before you even touch anything, I left these values blank on purpose because they're going to change when you do the sine of 2x. So the first thing that you want to do is you want to do this, and you want to write all this stuff down so you get this. So the period, the formula is going to be 2 pi, I'm going to try to use omega like our textbook does. So omega is 2. So what we would have is we would have 2 pi over 2. The 2's would cross out, so we get a pi. So the period on sine 2x is no longer 2 pi. It changes to pi, all right? And that's how I get that then, okay? The amplitude on both of these is 1, okay? The number in front of the sign is going to be 1, okay? So that's not going to change like it did in the previous problems. So always start by figuring out the period. Now the key, this is the whole key right here, is to figure this increment out. So what you do is you take the period and you divide it by 4. Okay, and I'll explain why you divide it by 4. So what we do is the period is pi. Divide that by 4, you get pi over 4. Okay, like that. So that means that our x-axis is going to go by pi over 4. That's where the key points are located then. Okay, so what we'll end up doing on this then is I'm going to just count by pi over 4. Okay, and I'm going to do this. You don't have to write this down necessarily because you can do this in your head. I'm just going to start at 0. Then I'm going to go 1 pi over 4. I'm counting by the numerator. 1 pi over 4, 2 pi over 4, 3 pi over 4, and then 4 pi over 4 like that. We're only going to take this table probably through 2 cycles like that. Then I'm going to reduce this, and this is what I'm going to have you write in your table. We're going to start at 0 this time. Then we're going to go to pi over 4, okay, and then 2 pi over 4. Well, the 2/4 reduces to a half, so let's write that as pi over 2. Then I'm to 3 pi over 4, and then when I get to pi over 4 pi over 4, the 4's cancel out, so I'm at pi. So what that is that's your cycle. You've defined the x values that have the key cycle like that. 1, 2, 3, 4, 5. And see, that's the period. The period was pi. So when you count from 0 by that increment, you should end up at the period. Okay? And what we do is we just continue out with this counting like this. So if I go down here, I'm just counting by the numerator. So I'd have 5 pi over 4. Then I would have 6 pi over 4, 7 pi over 4, and eventually I'd end up with 8 pi over 4. And what I'm doing is reducing the fractions. So 6 pi over 4 is 3 pi over 2, and then 7 pi over 4 is already reduced, and then 8 pi over 4, of course, is 2 pi, like that then. Okay? So when you have a number in front of x, that changes the period, so that means the way you do your graph is going to be totally different. Okay? Now, all I'm going to focus on mostly for the graph is just this part right here. Okay, so let's go ahead and let's go to our graph and let's just get this put together like this. So let's put now a pi over 4 there, and then pi over 2, then 3 pi over 4, and then pi like that. Okay, and then we're going to go backwards into the negatives just so it'll fit on our graph here. So I've got negative pi over 4, negative pi over 2, and so forth. So you want to get everything nice and set up there. Okay. Now I'm going to fill out this table of values kind of in a certain way. So to begin with, I'm just going to look at the sine, and I'm only going to do these values right here. Just those values right there, because those are the main values on the sine. We're going to do this then. So again, if you do the sine of 0, the sine of 0 is the y value, so that's 0. The sine of pi over 2 is 1. Whoops, don't put it there. Put it under the pi over 2. We don't care about pi over 4. Okay, so that's going to go to 1. Sine of pi is going to go to 0. 3 pi over 2 goes to negative 1, and then back to 0 like that. Okay, now let's just plot those points. Don't worry about the pi over 4. Pi over 4, the sine is square root of 2 over 2. Okay, that's a decimal. So plot these points kind of carefully. So let's do the y-axis, just needs to go up to 1. The amplitude is 1 on this problem, so we only need to worry about going from negative 1 to 1 on our y-axis. Okay, so let's plot these points. So we would have 0, 0. Be sure you go to pi over 2 and up 1, and then go to pi, and go like that. And then we're just going to kind of put this like this, and that would be like half of a period like that. And then I'm just going to kind of go backwards. If you did the sine of negative pi over 2, then it would go down to negative 1. And if I go to the sine of negative pi, that'll go back to 0 like that. Okay, so that is a one period of the sine like that then. Okay, now I want to show you how the mathematics works on this, but actually what happens is this. This is how easy it is to get your graph. So what happens is we're only looking at this part right here. That's one period of the sine of 2x. So it's going to end up being the same. This is going to go 0, and then it's going to hit the high point, and then back to 0, then to negative 1, and then to 0. So you don't have to crunch all those things out, because all that's happening is the x values are changing. I'll show you in a minute how the math works on this, okay? So we're going to do that, and let's go ahead and plot these points then. So now we have 0, 0. Now we have pi over 4, 1. And then we have pi over 2, 0. And then we have 3 pi over 4, negative 1. Then we got pi 0 like that. So this graph that I'm trying to draw in green, that's the graph of y equals sine of 2x. Okay, like that. So what happened is, okay, you learned this early in functions, we call that a horizontal shrink. Okay, so because that number 2, that number is bigger than 1, that causes the waves to go this way. Okay, the period changes. Now I'm going to show you kind of how this works, and I'll just take my unit circle and I'll show you on that. Now see, the nice thing about this is, you don't have to crunch anything out. The next point's going to go negative 1, 0, 1, 0 like that. So once you get a couple of points, you know the cycle and the pattern, so you can go ahead and fill out the rest. So I'm going to just put in the rest of the points on the green graph here, and then that gives you what we get. So I'm trying to show you how this compares to the original graph. Okay, now I'm going to show you how the math works on this. I won't do this on every single problem, but I want to show you kind of how this works. You don't have to write this down, but if it's helpful to you to understand, then it's worth doing. So I'm going to start at x equals 0, and then I'm going to go to x equals pi over 2, then I'm going to go to x equals pi and just show you how the math works. So what we're doing is we're doing the sine of 2 times x. And I'll show you kind of this, just how this works on the unit circle. I'm going to do the sine of 2 times x and just prove to you how this works, okay? Because we're graphing the sine of 2x. So this, if x is 0, you would do the sine of 0. Well, the sine of 0 is 0, okay? So that verifies that point right there. If you do the sine of twice pi over 2, well, what happens to the 2's? They cross out. So what you're really doing is the sine of pi. Well, the sine of pi is 0, okay, like that. Okay, so that's how we're getting those y values like that. And I'm going to do one more here. I'm going to do pi over 4. So if I did the sine of 2 times pi over 4, that's really the sine of pi over 2. And if you look at my unit circle, the sine of pi over 2 is 1. So that's how the math does. What it's doing is it's doubling the angle, then taking the sine. And that's how you get those same values. So what we did is we found the correct way to get those key values on the x-axis. Find the period, find the increment, okay? And then what's going to happen is the y values don't change. It's the x values that change. One thing that you may remember when we were talking about functions is, and I want to kind of review this just for a minute, and just talk about the difference between two things. This is the way all functions work. If the transformation is outside of the function, it affects y values. So an amplitude affects y values. If the transformation's inside the function, it changes x values. And that's what we did, is we changed those x values. Okay, does that make any sense? Right? That's a little harder, but if you follow, you know, finding the period, finding the increment, it actually makes this go real simple. Okay, you can check and verify these things on a graphing calculator, but you want to try to get these things put together by hand. Okay, so everything shrunk, the x values changed because the period changed. Okay, all right, let's do one more of these, and then I think I'm going to let you maybe try to put one together in class here today, and work with it. Let's go ahead and do this one. We're doing -2 cosine 1/2 x. So the first step is, tell me what the amplitude is, just by looking. Okay, it's +2, right? Yeah, it's always positive, remember that. So absolute value of -2 is 2, all right? So that tells you that the graph's going to change this way, okay, in the y direction. Okay, the period has the formula 2 pi over absolute value of omega. Omega in this problem is 1/2. So you're really doing 2 pi divided by 1/2. Okay, that's your omega, is the number in front of x. Okay, well that's really 2 pi times 2 over 1, so that is 4 pi. So the period has changed to 4 pi. It's gone from 2 pi to 4 pi, so the graph is widening out on this then. Okay? So always start that way, find the period and amplitude and get that out of the way, and then the key is to figure out how to do your x-axis, okay? So what we do on this is we do the period, and we divide it by 4. That ends up just finding for us where the 5 key points go. So the period's 4 pi, I divide that by 4, then I get pi. So our increment is pi, all right? So that means when we do our x-axis, we want to go by pi. All right, now I'm going to do this kind of same thing on here. Now I'm going to do this a little bit differently on this. I'm going to kind of go like this. I'm going to have you just count by pi like this. So this is really 0 pi, 1 pi, 2 pi, 3 pi, 4 pi, like that. I want to kind of have a little gap in the middle like that. Okay, all right. And what we're going to do is these are kind of the key points on the final graph that we're going to do. That's where you're going to get your 5 key points, is like that, okay? Well, let's go ahead and let's go down to our graph. Before we start crunching stuff out, let's get everything set up. So we're going to go pi, 2 pi, 3 pi, 4 pi, like that. And then you can do the negative ones like this. Okay, and then the next thing that I like to look at is, okay, let's think about the y-axis, okay? Well, if you have an amplitude of 2, then you want to go -2 to 2. But you're switching everything up 1. That's taking everything up 1. So instead of -2 to 2, you just want to bring that up probably all the way up to 3. 2 plus 1 is 3. So a logical way to scale the y-axis on this would just be go 1, 2, 3. And then -3 like that, okay? All right, does everybody understand how I got the period and increment? Everybody with me there? That's the whole key to doing these problems, okay, is figuring that out, okay? Now, what I'm going to do is this. I'm going to go ahead and fill this out. So let's get the cosine of some of these key values. So the cosine of 0 is 1. I'm going to go ahead and put a pi over 2 in there. Cosine of pi over 2 is 0. cosine of pi is -1. Then if you go to 3 pi over 2, which I'll put in here, that takes you back to 0. Then the cosine of 2 pi is, cosine of pi, pi is -1. Cosine of 3 pi over 2 is 0. Okay, then when you get back to 2 pi, then you're back to 1. Okay, so that would be like one cycle like that then. Okay, and that's all I'm going to do is just have you plot just this little piece right here on the cosine. So we've got 0, 1. Pi over 2 is halfway between 0 and pi, so that's 0. Then you have pi -1, and so forth like that. That would be the period, just one period of the cosine like that. Now I'm going to show you how to put the whole thing basically together based on that basic graph there. I'll show you what calculations I do. Okay, now I'm going to write down what I do on this problem, and it really boils down to doing arithmetic on this. So what we're going to do is, and if you got room on your paper to write this down, you probably should somewhere at the bottom or something. We're going to work with x equals 0, x equals pi, x equals 2 pi, x equals 3 pi, and x equals 4 pi. With a little practice, you can learn how to do some of this stuff in your head. But what you end up doing is you end up doing this then. Okay, I'm going to highlight the key numbers. -2 and 1 are the key numbers. What we did is we have the answer to the inside part of this. Okay, what we have is those are going to be the same as these numbers right here then. Okay, so what we're going to do on this then, when we go to x equals 0, then what we do is we do -2 times 1, and then we do +1 like that. Okay, so we're gonna end up doing that. All right. So when I do that, then that's just going to be -2 plus 1 is going to be -1 like that. All right. So that first value right there just becomes -1. Okay, like that. All right, because what we're doing is we're taking the y value that we already have from the cosine and we're manipulating it then. Okay, so that's what we're doing. Okay, when we go to the next thing on here is, now we're going to go to the 0 here. So the next thing we're going to do is we're going to go -2 times 0 plus 1 like that and work that out. So that would be just equal to 1. Okay, so when we get to x equals pi, then that's going to take you back, that's going to take you to a 1, like that. Now I'll explain kind of where I'm getting these y values in just a minute. There might be a little confusion. What I'm looking at is these numbers here from the cosine. I'm not looking at, like, if x is pi, I'm not looking at -1. I'm going through the cycle, 1, 0, -1, 0, 1, like that. Okay? When I go to the next one, I do -2 times -1 plus 1. So that gives 2 plus 1, that gives 3. Okay, like that. Okay? And then I move on to the next one. I go -2 times 0 plus 1. So that's going to give back to 1. And then finally I do -2 times 1 plus 1, which would give back to -1 like that. So I want to show you something on this. And this is what some of you might not be catching, okay? See those points right there that I highlighted, 1, 0, -1, 0, 1, those are the y values on the basic on one period of a cosine. And that's what you're changing, is those things right there, okay? So what we're going to do then when we fill this out is it's basically going to go like this then, okay? If x is equal to 0, we get -1 there. If x is equal to pi, we get a 1 there. You're going to get the 5 key points. And then when you go to the next one, x is 2 pi, we're at 3. Then when x is 3 pi, we're at 1. And x is 4 pi, we're at -1 like that. Those are the key points, -1, 1, 3, 1, -1. Okay? So what I'm trying to get you to kind of understand is really what happens since the period changed. The key x values are 0, pi, 2 pi, 3 pi, 4 pi, like that. But what you're doing is you're just manipulating the basic numbers on a cosine graph to get the final product. Okay, so it's really arithmetic when you get right down to doing that. So now what we're going to do is we're just going to plot these points. So we have 0, -1, and I think you'll see visually what it's doing. Then you go pi 1, so we have that. Then we have 2 pi 3, 3 pi 1, and then 4 pi and -1 like that. So that actually would give you one period of that graph like that. So it's got every key point on it that you have. And what you guys got to understand on this, see, is basically if you look at this, it got reflected. You can see that the maximum flipped down to a minimum. So it got reflected. It got stretched. Okay, the amplitude is the distance from, half the distance from -1 to 3. So the amplitude is 2. That graph is showing you half of that distance is 2. And then the period widened out. And everything got switched up 1. So it's all of the same basic things there. This is what some of you might not be real clear on is right here. But again, once you figure out where those key x values are, then you're manipulating the basic 5 numbers in a cosine graph. Okay? That's why I'm doing that. So all that right there is just doing what that function tells you to do. -2 times the value plus 1. Does that make any sense? Any question? Okay, it's all arithmetic. You gotta, when you're doing these things, you work inside out. These two numbers right here affect y values. That only affects x values. This part right here is not changing those y values on the original cosine. Okay, and that's a fundamental thing you want to get with functions, is the difference between inside the function and outside the function like that. Okay. Okay, so that's a way to do that. That makes that pretty simple. And once you catch on to this, you'll be able to begin to do this in your head pretty easily, actually. Okay. Okay, let's see. Let's go ahead and let's kind of start together on this one. And then I'll kind of get you what to finish up on this then. So what you want to start with on this one is what is the amplitude? Let's do the basic stuff first. So what's the amplitude? 4. What does that mean? Stretch. Okay, stretch this way, right? Y values get multiplied by 4. Okay, the formula for the period is 2 pi over omega, omega being 2. So what we're going to do is 2 pi over 2. So that gives pi. So that means from 0 to pi is where one period is going to happen. Okay? How do I find the increment? What have I been doing? Dividing by 4. Right, I do the period divided by 4. That basically breaks it up into 4 spaces, which ultimately gives you 5 key points. So the period is pi, and then you got pi over 4 like this. Okay, now this time I'm going to do something a little different. Okay, I'm not even going to bother with the sine thing, or that should have been a cosine anyway. We're just going to do the final thing. That's ultimately what you want to do, is just do the final thing. You don't always have to do that basic graph. The purpose of that was to show you how the period was changing in relation to the basic function. So here's what we do. Start counting by pi over 4. Okay, and you can do this in your head if you want to. So 0, pi over 4. You want to reduce your fractions. 2 pi over 4 would be pi over 2. 3 pi over 4. And then we would finally get to 4 pi over 4 like that. Now I'm going to do the problem the way I usually want you to do it. Usually I just want you to do one period. If you can do one period, you can do as many as you want to. Theoretically, it's all the same. So that's all we're going to do, is just focus on that part of this table when we do this. Okay, so basically what we want to do is let's get our graph set up just with these values. So we've got pi over 4, and then pi over 2, and then 3 pi over 4, and then pi. Now let's think about the y-axis, okay? Well, that stretches it from, that thing right there stretches it from -4 to 4. What does the -2 do? Down 2, okay? So probably if you're -4 down 2, you probably want to go down to -6, okay? You can tell by those numbers how to scale your x-axis. So that 4 and negative 2 are kind of key. So let's go like 1, 2, 3, 4, 5, 6. I'm just going to extend my graph down to negative 6. And then maybe up to 4 like that, and that's good enough. Okay? So what I'm going to do on this is I'm going to show you, I'm going to move this unit circle out of the way, and I'm going to show you how you can put this together. The whole thing together like this. So really what you're doing is the key values go like this. On a cosine, the key y values are 1, 0, negative 1, 0, 1. If you look at my unit circle, what I'm doing is I'm getting those values. Remember, the cosine is the x value. So what I'm doing is this. The cosine of 0 is 1. Cosine of pi over 2 is 0. 1, 0, negative 1, 0, 1, like that. Now see, those y values are not going to change. It's the x values that change, the period. So what I do to get my answer, the arithmetic I can do, and you can just write this on the side if you want to like this, is we have figured out where the x values locate these key points. So now we work with the 4 and negative 2. So this is all you do in this order. You just go 4 times 1 minus 2. Okay, that's taking that basic first cosine value. Then we go to what? 4 times, what's the next one? 0 minus 2. Okay, like that. Okay, then we go to the next one. We do 4 times negative 1 minus 2. Okay, then we go to 4 times 0 minus 2, and then back to 1. Okay, what you want to understand on this, see, is that these numbers here are, they're not affected by the period change. They're getting ready to be affected by the 4 and negative 2. So this will give you the basic values. So we just work it out, and then we're ready to fill out our table. So 4 minus 2 is 2, so we get a point there. This would be 0 minus 2 is negative 2. This would be negative 4 minus 2 is negative 6. This would be 0 minus 2 is negative 2. And then 4 minus 2 is going to be 2 like that. Okay, you're going to know if you're on the right track. I mean, it has repetition. It's got 2 2's and 2 negative 2's. Okay, so everything should be the way it needs to be. Now let's just plot the points. So we have 0, 2. We have pi over 4 negative 2. Pi over 2 negative 6. 3 pi over 4 negative 2. And then pi 2 like that. So ultimately, what I like to try to get students to do is to forget about that table of values. It's really just figuring out if there's a period change, what are those key x values, and then doing that manipulation. Those things on a cosine are going to always start that way. If it was a sine, it would be 0, 1, 0, negative 1, 0. Okay, you're just taking that like that. Does that make sense? So it's really arithmetic. When you get right down to it, you got to know the basic concepts, but then it's arithmetic. And that did everything we expected it to do. You can tell the amplitude is 4. You can tell it's been switched down too. If you look at that graph, you can tell all of those pieces from that. Okay? Okay. So let's go down this next one. And again, this one we're going to try to just no table, just do it all in our head. That's the goal. All right, so this one we're graphing 3 sine of 4x. And this goes like this. Okay, so what's the amplitude? 3. I can tell everybody's got that down. How do you find the period? 2 pi over omega. Okay, so that would be 2 pi over 4. That reduces to pi over 2. Okay, period changed. How do you find the increment? Divide by 4. Exactly. So you take the period and divide by 4. You can also think of it as multiplying by a fourth. Dividing by 4 and multiplying by a fourth are the same thing. So that would give you pi over 8. So what do you do with that pi over 8? What is the point? Well, that gives you the x value. So you count by pi over 8. So you don't need to make a table. I'm just going to write this. You can do this in your head. I'm doing 0, 1 pi over 8, 2 pi over 8. I'm counting by the numerator. 3 pi over 8, 4 pi over 8. Okay, like this. And then some of these fractions reduce, so reduce them. So we're going to have pi over 8 here. The 2 pi over 8 reduces to pi over 4. And then you got 3 pi over 8. And then this one reduces to pi over 2. Now, you always kind of, when you're learning math, self-check yourself as you go. It's real easy, okay? What is the significance of pi over 2? That's very important in this problem. What does it mean? It means the period. And then count the 5. 1, 2, 3, 4, 5. You ended up where you're supposed to end up. The reason we divide by 4 is there's 4 spaces make up those 5 key points. That's the reason we do that, okay? So we got that. And basically on this, well, let's see, what's a good way to do the y-axis on this problem because of the amplitude? Negative 3 to 3, right? Its amplitude's 3. So the good way to do this would be go up to 3, go down to negative 3, and then we're going to start kind of putting this all together then, okay? Now, with practice, you start kind of doing this in your head. So the idea is when you're doing a sine, I'm going to highlight how these y values go. What we're doing is manipulating these y values. And all we're doing on this one is multiplying by 3. So I kind of start like this. The first key point, I'm doing 3 times 0. The second key point, I'm doing 3 times 1. The third key point, I'm doing 3 times 0. The fourth key point, I'm doing 3 times negative 1. And the fifth point, I'm doing 3 times 0. Okay, so again, I'm working with a sine wave. So the sine starts at 0, hits a high point, back to 0, low point, back to 0. That gives you your y values right there, okay? Now, so you can do this all in your head now. So this would be 0. So there's your first point, 0, 0. Okay, the second one would be 3. So it goes like that. Next one goes to 0. And then this one goes to negative 3. And then the last one goes to 0. There's your graph right there. I didn't do a table of values. Didn't really have to do much of anything except know that I'm manipulating the sine wave like that. That's it. Is that easy enough? Okay, it's not that hard. This is the way I teach it. Now, my math lab may do something totally different than I do. I don't know. I used to teach this way different than I do now, but this to me is the most logical approach when you have a period change, is figure out those key x values and then manipulate the y values kind of in that order. Okay, that's it. You can always check on your graphing calculator. Okay, any questions so far? Okay, it takes practice like anything else. All right, so let's see. Let's go on to the next page. This is stuff we've already learned. We've already talked about that. If you have a plus c and a minus c, it's up or down. Okay, we've already learned that. So let's see. Last couple of things I want to do on here is just kind of some basic stuff here. We're not going to graph on this. I just want to kind of do a summary of the key stuff on here. Okay. So the first one, the amplitude is absolute value of negative 6 is 6. The period is 2 pi over omega, with omega being 3. So that's 2 pi over 3. Okay, the increment of the x-axis, you always take the period and you divide it by 4 or multiply by a fourth. Okay, it's the same thing anyway. So this you would reduce the fraction. 2/4 reduces to a half. So that increment on that would be pi over 6 like that then. Okay. Now let's think about the minimum value of y on this problem. The key numbers that are manipulating y values are the negative 6 and 5. So the way I look at it is like this. Okay, what you basically have is the minimum is negative 6, but you're taking it down 5. The maximum is positive 6, but you're taking it down 5. If your amplitude is 6, then you have negative 6 and 6, but then those numbers got to go down 5. So that minimum is negative 11. That maximum is 1. Okay? The vertical translation on this problem is just down 5 like that. Okay? And that's it. Okay? Go ahead and take a couple of minutes to fill out that next one. Let's make sure that we kind of got the overview here, and then we'll wrap up the section with kind of the opposite thing where you're given a graph and then you're writing the the trig function on that then. And by the way, on the period on this problem that I'm having you do, the pi's will cancel out. That's not a bad thing. That's a good thing. Okay, if you do the graph, it actually makes the graph somewhat easier if the pi's cross out. So see if you've got it all put together here. We're supposed to get a snowstorm again. All right, I don't think it's going to close. I have a feeling it ain't going to close no campus, though. It was raining when I was walking here, so it looks like it's going to rain until like about 5 o'clock or so. This is going to be a sloppy, slushy mess. That's what I said last time, though, and then I didn't have to go to work the next day. So who knows? Okay, well, let's see. What's the amplitude on this one? That's 1. Okay, there's nothing in front, so that's 1. Okay, now the period is 2 pi over omega. So I kind of look at this like this. You're doing 2 pi divided by pi over 4. Okay, well, when you divide a fraction, you multiply by the reciprocal. So it would go like that. Okay, so what you'd have is 2 pi times 4 over pi, so you would end up getting a period of 8, which is okay. All right, what's the increment going to be then? 2. Yeah, you take the period divided by 4. That gives 2. So if you were graphing this, you would just go 0, 2, 4, 6, 8. That would be your x-axis. Okay, now the way I look at this, if the amplitude's 1, then the minimum's -1 to start with, but you're adding the 1, so that means the minimum is 0. And then the maximum is 1, but you're moving it up 1, so you'd have 2. Now that's fundamental stuff when you're learning the graph of a sine and cosine that you want to quickly and efficiently always be able to do is figure out those things. That's the whole key to that, is reasoning all that out. Okay, is there any question about that? Okay, so I think we'll wrap up with just kind of doing the opposite thing here, where I give you a graph and then we're trying to write the trig function. And that's a pretty common thing in practice and applications, is we model stuff with sines and cosines. All right, so I think I'll do 2 of these and just kind of show you what we're doing on this. So really what our goal on this example 1 down here is to write what this function is. So this is what I suggest you do. I would suggest that, and you can do a sine or cosine. We're not ready to do a sine or cosine on both, but what I'm going to suggest is, if that midpoint is on the x-axis, you want to use a sine wave on this. Okay, and on this next example that's on the next page, if it starts at the high point, okay, you have a max where it starts, then you want to use a cosine. Okay, because you wouldn't be ready to write this thing as a sine because you hadn't learned about phase shifts yet. So that's kind of a key thing. You got to figure out, do I need a sine or do I need a cosine? Cosine starts at high point. Sine would kind of start at that midpoint like this. Now, if you look at this graph, you can tell it's been moved up. Okay, you can tell that. So what we're going to do is we're going to figure out from here the period, the amplitude, A and omega. Okay, that's what we're going to do then. All right, so first of all, the amplitude on this is half the distance from the max to the min. You can do this in your head. You don't have to necessarily do this. It's just half the distance from 1 to 3. So that would be half of 2. So that would be equal to 1. So what that means is A in the formula is 1. Okay, the formula we're going to use is y equals A sine omega x. We're going to model it with that, and then we'll probably also have a translation on that then. Okay, next thing we want to do is we want to look at the period. Okay, well, the period, you just pick a point and start. I usually just start at this point here and count out 5 key points. So that would be 1, 2, 3, 4, 5 key points. So your cycle is from there to there. So that means the period is 2 pi. So we don't have to worry about a period change on this problem then. Okay, so we got that. All right, this thing called the midline is just sort of helps you see the symmetry of this. That would be y equals 2. That's just kind of a line that's symmetrical about like that. So basically what we would have on this then is we would have this. Now to find omega, you have the formula 2 pi over omega is equal to the period. So what I'm going to do is, since the period is 2 pi, I just get 2 pi over omega equals 2 pi, and I can solve that equation for omega. Well, you can do this one in your head. What's omega have to be? If I have 2 pi over omega equals 2 pi over 1, what does omega have to be? It has to be 1, doesn't it? Okay, so we got everything we need then. Okay, so what we have then is the amplitude was 1, that goes there. Omega is 1. Anytime the period's 2 pi, omega is going to be 1. So what happened is this thing moved up. The sine wave looks like this. So this value moved up 2. So then that goes like this. So then the final answer to this problem would be y equals 1. You don't have to put the 1s there, of course, but you would have that. So it'd just be sine of x plus 2. Okay, that's what the function is that I gave you a graph on. What you're ultimately doing is you're finding A, omega, and B based on what you have. You have to understand how to figure out the amplitude and period and whether to use a sine or cosine. Does that make any sense so far? Okay. All right, let's finish up with this last one here, and that'll wrap us up. Okay, so we're going to do a cosine on this. Okay, so the amplitude is going to be 1/2 the max, which is 2, minus the minimum, which is -4. Okay, that's always half the distance from the max to a min, so that's half of 6, so that's equal to 3. Now that means we're going to get, in our formula, A is 3. Okay, the period, it doesn't matter where you start, I'm just going to start here. Count out 5 key points. 1, 2, 3, 4, 5. Okay, that's a cycle of the cosine. What is the period on this then? It's the distance from there to there on the x-axis, which is pi. So that's different now. Okay, so we have to use the formula period equals 2 pi over omega to find what omega is in our formula. Then we can wrap it up then. Okay, so I'm going to do this like this. The period is pi, so I have the equation pi over 1 equals 2 pi over omega. You can solve that by cross-multiplying if you want to. So we have pi times omega equals 2 pi. Divide both sides by pi. So you would get the pi's crossing out, so omega is 2, like that. Okay? So anytime you find omega, you have to get the period and use that formula to find that. The midline on this one would be going right through, that's just half the distance from the min to the max, so that would be y equals -1. Okay, so when you put the final answer together, we're looking at this basically. We're looking at y equals A cosine omega x plus b. Okay, the amplitude was 3. Omega we got was 2. Now all you got to do is kind of figure out how this thing changed on this then. Okay, and what you do on that vertical translation is you're always kind of looking at, I kind of look at this midpoint right here. What happened on this problem is if it was a basic cosine, that would be the midline. Well, that thing moved down 1, see, okay? So this whole thing, see, if the amplitude's 3, we would go from -3 to 3. But we moved that maximum of 3 down from the amplitude down 1, so that's going to be down 1. Okay, so B is going to be -1, so the answer to the problem would then be y equals 3 cosine 2x minus 1. And you can check on your calculator. I mean, you could put 3 cosine 2x minus 1 in and give you the same graph. Okay, so that's we'll work on that a little bit more next time. But the key is figuring out those pieces: the period, the amplitude, and the up-down thing. Okay.